Good evening, everyone. Quick comm check with Neil at the back there. Yeah, cracking. Great to see such good attendance. Welcome to the 2023 Alan Bristow Memorial Lecture. We're very privileged to have two excellent presenters who've come all the way down from Aberdeen to present to us on the topic of joint helicopter and UAV operations in search and rescue. A couple of housekeeping announcements before we get stuck into it. So there's no planned fire alarm test in the building today. If there is an alarm, please use the exit behind us and the society staff will help you out there. There's a designated assembly point in the paved and railed area at the junction of Hamilton Place and Piccadilly, beyond the Intercontinental Hotel, but you will be guided. If you do have any mobility issues, please let a member of staff know so that they can make sure that you're okay. Please also don't leave any unmarked bags or any other items unattended. Mobile phones to silent or off, please, as well. And just to let everyone know that the event is being recorded and will be available on YouTube after the event, so about 2 or so weeks as routine. After the presentation, there will be an opportunity to ask questions. There's a mic over there, so please step up and ask them. And unfortunately, we do have to close pretty sharply at 1900 hours. So just a little background on the Memorial Lecture itself then. So this is to commemorate a great pioneer of helicopter operations. So Alan Bristow began his flying career in the Royal Navy during World War II, after going AWOL from the Merchant Navy, being amongst the first to train on helicopters in 1944. He was the first to land a UK helicopter onto a Navy ship. After the war, he joined Westland Helicopters as a test pilot and then worked for Sud Aviation, now Airbus. During a sales tour in Indochina demonstrating the Hiller, he rescued some injured French Foreign Legion troops trapped by the Viet Cong. He was later awarded the Croix de Guerre. He then moved into whaling, clearly a very colourful background, first using helicopters to spot whales and then using an airborne harpoon to kill them. The next step was from whale oil into mineral oil, and Bristow Helicopters was formed to support Shell in the Middle East. From there, it grew worldwide, mainly working in the oil industry, but also in military training and SAR. The first UK Coast Guard contract was at RAF Manston in 1971. Alan Bristow stepped down from Bristow Helicopters in 1985. So and we run one of these every year around this time. So as I mentioned, we're very privileged to have two excellent presenters today. So first off, we've got Graham Hamilton, who is a fellow of the Royal Aeronautical Society, and he is the UK Search and Rescue Director, reporting directly to the Chief Operating Officer for Government Services. He is responsible for the day-to-day search and rescue operations in the UK and the Falkland Islands, and delivery of uncrewed air systems in the UK in support of Operation Caesar. Graham served 32 years in the Royal Navy as an aircraft engineering mechanic, before being commissioned as an air engineering officer. Graham's final appointment in the military was as the Senior Engineering Investigator at the Military Air Accident Investigation Branch. After leaving the Royal Navy, Graham worked in the oil and gas industry in Scotland and Norway as the head of offshore safety for Bureau Veritas, ensuring compliance with safety regulations in the offshore industry. Graham returned to aviation and joined Bristow Helicopters Search and Rescue as the UK SAR Safety and Compliance Manager, a position he held for 5 years before becoming the UK SAR Deputy Director, where he's been responsible for starting the UK SAR 2G project delivery programme, and recently has taken up the role as UK SAR Director. We're also joined by David Scott, who is the UK SAR UAS Operations Manager, reporting directly to the UK SAR Deputy Director. He's responsible for developing and establishing the Maritime and Coastguard Agency's very first unmanned aircraft capability, designated Coast Guard 50 Unmanned. David is responsible for concept of operation development, operational oversight, and overall UAS service delivery. Prior to joining Bristow Helicopters, David served 12 years in the Royal Air Force as an aircraft engineer, spending the majority of his time on Tornado GR4 squadrons, supporting UK training operations in the UK and later on operations overseas, operations Telek and Herrick, where he first encountered unmanned aircraft or worked on. On leaving the service, David transitioned into the oil and gas industry as a remotely operated vehicle pilot for Subsea 7. David went on to conduct subsea operations in Scotland, Norway, the United States, and finally Brazil, before deciding on a return to aviation. Recognising the future potential of UAS, David welcomed a return to the aviation industry as one of the founding members of Bristow Group's first steps into the unmanned aircraft market through the establishment of Bristow UAS. David held the position of UAS Operations Manager and led the company's diversification and regulatory development to establish Bristow as a market leader in complex UAS operations. Initially focused on oil and gas operations, David led the development of the company's complex Beyond Visual Line of Sight program, focused sharply on evaluating UAS in the search and rescue role. This work ultimately culminated in the award of the UK's first unmanned aircraft capability for HM Coastguard. Without further ado, that was quite a lengthy introduction. The floor is yours, gentlemen.
Well, thanks, Neil. I think we just covered the whole presentation. That's got you in your bio, so there's no point in carrying on. Good evening, everybody. Graham Hamilton, for those who don't know me. It's a privilege to be the UK SAR Director. Previous UK SAR Director sitting at the back to make sure I don't, put my foot in it in any way. But the reason he's here, because the three of us were involved right from the start. So I was in the safety management, Neil was sitting as a deputy director, moving into director's role when we brought the UAS service from where it began, looking after oil and gas offshore, doing surveys, all the way through to where we are now, operating in the channel in support of the Coast Guard. We're not going to talk about that part tonight. We'll get you there. That journey will get us there. But we're not going to actually talk about the operations in the channel because that's ongoing with the Coast Guard and it's their information at the end of the day. So, slide one's working, we're okay. It's also an honour to be here. Alan Bristow is a great innovator. We're here to support that and continue on with his sort of legacies in there. So what I want to do is take you through this development path that we went through all the way back to sort of 2016 when we began. We're going to walk through how we did our oil and gas assets, our integrity inspection, moving then on to sort of the EV loss, the extended visual line of sight, where we did helicopter landing, moving then into the operational safety cases, which I was involved in with David, and then finally bringing in the S100 into service for us to trial the various systems that we're going to talk about tonight. And we'll take you through every stage of this journey before we finally take on the Overwatch operations in North Wales and we get to the LID operations where we're operating with the Coast Guard now, live operations on a daily basis. So that's the kind of the background. We're also going to talk about how we brought all the stakeholders along with us, how the regulators come on the journey with us. We're going to show you how we've had to adapt all the rules and regulations as we go, working closely with the regulator, working closely with the stakeholder groups. One of David's big headaches is working with all these different groups to try and bring them together, and how we reached the UAS prototype service that moved into the delivering of the S100 service. That's the kind of journey we want to go on tonight that gets us to where we are today, operating out of LID, and then into the future. So David, despite your long bio, take us through the bio again.
I'll do my best, thanks Graham. So back to the very start then, the easy to do visual line of sight operations under a standard VLOS permit. So 500 metres distance from the pilot, up to 400 feet maximum altitude. Back then, this was called the Permit for Commercial Operations, or PFCO, and we secured our first sub 7 kilogram PFCO in 2016. We deployed the Aztec Falcon 8 small uncrewed aircraft. You can see the yellow aircraft here with the camera fitted for on and offshore oil and gas integrity inspections. The F-8 itself is a small and lightweight drone equipped with several different payload options, providing HD video, thermal IR, and HD stills. This is the HD stills camera you can see here on the screen. Data captured by the drone was then used by installation managers and onshore engineers to determine the asset integrity of essentially the rusty oil rig or the flare tower, so they could look at the state of the corrosion on those vital structures. Ship's hulls as well, flare towers as I mentioned, the latter not requiring to be shut down for that inspection, so obviously saving time on downtime for that rig or FPSO. Getting slightly more difficult then, oil spill response. In parallel to the asset integrity operations, we use the same basic VLOS principles and approvals to deploy small UAS again in support of emergency response to oil spill. You can see in the picture in the middle here, this is an oil spill response vessel in the middle, which we deployed the aircraft from, and these are the IR stills from that aircraft. The darker patches that you can see here is the actual oil on the surface of the water, which stands out, as you can see, really clearly. This is also the first time we began to live transmit payload data from the drone in real time to scene commanders, so they could make best use of the assets and the dispersants and the detergents at their disposal to react against the oil spill itself.
The more observant, David's beard gets longer and shorter throughout this presentation.
Getting slightly harder again, as we mentioned earlier. Now moving on to the more difficult to do. We secured additional CEA permissions to begin to extend the useful operating range of small UES. This was done under an extended visual line of sight permit, so EVLOS now. We operate in highly congested urban areas. This was backed by a robust CONOP, and our new approvals authorised the flight of the DJI M200 Matrice drone, which you can see on the bottom here, outfitted with a ballistic recovery parachute to mitigate against flying over those congested areas, which included city centres, etc. The drone itself, it was used to conduct pre-planned survey missions out to distances of over 1 kilometre from the pilot in command. It was used to gather photogrammetry data of the site for post-processing. The post-processing involved building large orthomosaic maps and 3D models of each individual site. We could then take proposed planning for different buildings, you'll see that in the video in a second, and import that into the 3D models so the actual site managers could ascertain the impact of that new development. The pink you can see here, again you'll see that in the next slide, represents the approach path for an S-92 helicopter. This takes a couple of seconds to start this one. So on the far left, this is a proposed building. So we imported architectural data into the model. And you can see the impact to the flight path here of those close houses that penetrate the flight path. So we can go back to the site managers and say, you need to fell that tree. This is an area of issue. We may need to move that approach or departure path for the helicopter itself to make it safe, essentially. Again, more proposed development work here. And the model you're viewing now, as I said, this is built up of thousands and thousands of individual photographs taken by that small unmanned aircraft. For those of you who don't know, ARI, Aberdeen Royal Infirmary. Graham?
Okay, so that's where it began. So David and his team are working away with these small aircraft, but the market is pretty saturated. We've got lots of people out there. You could just be a one-man band to set all this up if you wanted to, as long as you've got the IT to lean back on and the processing power. So now it's time for us to do what we need to do. We need to innovate. We need to look in a different direction. So this is where we are now on our sort of journey through to the UES. We're now starting to think, what platform do we actually want? So 2018, 2 years now of operating with the small drones. We're now looking for something to change the playing field, something to bring into search and rescue. We're asking ourselves lots of questions. Can we take the search out of search and rescue? Can we do this? Can we do that? We're never going to replace. Some of the crews thought we were going to replace the crews. Can you imagine a UES turning up with the mini winchmen getting out and rescuing you? It's not going to work. That was the sort of fears that we were having to overcome. But first of all, we had to decide what platform we were going to go for. We then had to decide what systems we were going to test on the aircraft and how we were going to integrate those into search and rescue services. So here's the jolly team. There's the guy right at the back there who's in the middle, and Scotty's there on the picture as well. Yeah, so the evaluation, this is the S100. This is the first time it's seen in its civil form. It's been used by military up until now. We went to the S100 because of its reliability. We knew it had been used. We knew there was parts, there was spares. We knew what the fuel burn rates were. We knew what sort of payloads we could carry on this aircraft. And this allowed us to down select to the S100. And this is the trials team doing this pre-selection and to develop the CONOPS in Wales to allow us to go BVLOS. And we had to secure permissions from the CEA. We had to bring in our stakeholders, the regulator. We had to show the DFT. We had to show the MCA that we could manage all this and do all this. And this is what this trial was all about. It was not only down selecting the platform, it was proving that we could do the concept of BVLOS out there. So David, do you want to talk us through this video?
Yeah. So this is really the culmination of that week of demonstrations. 2 days of simulated rescue events in which the interoperability of the UK SAR HS92 from Carnarvon and the S100 was proven through manned, unmanned teaming exercises carried out in the Cardigan Bay. Essentially involved dropping several simulated persons in the water or mannequins into the Cardigan Bay early in the morning. The S90 crew from Carnarvon did a great job doing that. They then came back to Lambedder, landed on, and the S100 was then tasked to go and look for those simulated persons in the water. Once located by the S100, the positional data was relayed back to shore through a sort of false rescue control. Only then was the S92 deployed to conduct the rescue. So we're taking the search element out of the equation. This is being done by the unmanned aircraft, and this is the most efficient use at this stage of directly responding with an S92 to do what they do best, put a guy on the end of the winch and recover the mannequin.
Cool. So we've now down selected our platform. We've now got to start thinking how are we going to integrate this into the search and rescue service. What sensor packages are we going to use? What are the ConOps going to be? How are we going to talk to crews? What other things can we do? Can we relay messages for other aircraft? Can we be overwatch? This was all the things we wanted to learn. We had to train the crews, the UAS crews, how to actually do search and rescue. Despite all the history we have of doing search and rescue in manned aircraft, we had to relearn those lessons in the unmanned world as well, or the uncrewed world. So this is us now. We're at 2021, 2020. In fact, we seem to have jumped ahead slightly. With the trials and evaluation for the BLOS and the operation of the Schiebel S100, the sensors and the payloads. And we're going to go through the payloads one by one in a minute and how we got there. And we're based now at Carnarvon Airport alongside our search and rescue asset. So we're now starting to bring everything together. We've got a search and rescue base with its 2 aircraft and its crews. And we've got the UAS assets sitting right beside that base, operating. At one point, we were trying to operate in the same hangar, and then something called COVID arrived. So we ended up having to separate the 2 crews out because we were trying to protect the integrity of the search and rescue service. So we still managed to operate the UAS, and we managed to operate the search and rescue helicopter, but in 2 buildings. But through common planning, ops rooms, using the experience of the SAR crew, the UAS crews were able to sort of learn their trade and their ConOps and develop them, and make some mistakes on the way, David, as well. Sure. Yeah. So, David.
So to conduct these trials, how did we do that? So we had to apply for a TDA complex through the CEA to secure airspace to conduct the trials. Essentially that involved securing 2 sectorised transit corridors, you can see in the picture there, one leading down the Clym Peninsula and one over Mount Snowdon. These all joined with Carnarvon ATZ, from which the aircraft was operated from, as Graham mentioned. Controlled operationally by RAF Valley ATC, who provided us with SSR radar coverage, allowing transit through cold sectors. As you can see, it's sectorised. That's intentional. So, for example, if the UES was down to the south, the SSR could clear aircraft through another sector. So, limiting the impact of that TDA on regional air traffic. As I said, all movements were coordinated by over VHF, over an agreed comms plan. Our US crews are all former manned or unmanned aviators, all with the right licensing, fertile, etc. The UES was operated from surface up to 8,000 feet AMSL. As I said, this included inland operations in mountainous regions like Mount Snowdon. Trials included running chosen payloads against known target sets in the maritime environment to determine detection ranges and any limitations of the aircraft and those sensors. We also conducted manned, unmanned teaming, as you've seen from the previous demonstration, conducted scene control operations with the UES and night operations ConOp development. The airspace was also used to validate the accuracy of the UES positional data, so the transponder systems, the electronic conspicuity systems, and other novel electronic conspicuity tech. So a little bit on the platform itself then, for those that are not familiar with the S100. Maximum takeoff mass of 200 kilograms. Speed of best endurance 55 knots, which coincidentally is a really good speed to be doing search activity on. It's very comparable to a manned aircraft. Max cruise about 80. It is capable of up to 90 knots VNE. Endurance, 5 hours 30 minutes. That's on a 57-litre fuel tank, so it's not thirsty by any means. Day and night capable, as I said. The operational range really limited by the type of control antenna that you've purchased from Schiebel. In our case, we have the 34-inch tracking antenna, which allows us to operate out to 100 kilometres range from the GCS, the ground control station. Multi-role configurable. Here you can see it just outfitted with the MX-10. We'll go on to talk more about the payloads in a second. But critically, the big change for us from a search and rescue and SA platform is the ability to live export payload data in real time into the control station and to the scene commanders in the HM Coastguard. At the moment, that's currently done with manned aircraft that's post-processed after flight. So the GCS itself then, what does that look like? It's a lot of screens. It doesn't look unlike an ROV suite from back in my old days. So you can see on the left-hand side there, the pilot station itself, where the aircraft is flown from. In the middle, all our comms, so our airband radio system, VHF. We have a TDA deconfliction chatnet running on the iPhone you can see in the middle. And the other basics you would expect of a normal office, really. Landlines, high-speed internet to obviously connect the computers with. On the right-hand side, this is where the payload operator and co-pilot operates the payload from. You can see down here on the right-hand side, I hope you can, this is the hand controller for the MX-10, the EOIR sensor, and also you can see the chest rig with the joystick on it. That's used at critical phases of flight by the co-pilot, who essentially goes outside, lands and departs with under VLOS at that critical stage of flight.
Okay, so we talked about the aircraft, we talked about how we got there, we talked about how we selected it. Now we need to look at the payloads. What are we going to actually use on this aircraft? So David's talked about the MX-10, so we're going for that. That's our basic fit, our basic capability on all our aircraft. We have 4 of these aircraft. 2 rolled in the MX-10 and PicoSAR role, and 2 rolled in the MX-10 and Ocean Watch role. But during the trials, we went through the PicoSAR, we went through Ocean Watch, and we went through the Thales iMaster radar. We wanted to understand how to use them, when to use them, more importantly, what conditions we could use them in, where the aircraft would have to be, what was the best height, what was the best speed, all to understand how best to use these systems on the aircraft. So David's just going to take us through now, some background on each of the payloads. Not too much, though.
No.
Hold yourself back.
Will do.
Okay.
So without going into too many specifics, obviously, as Graham mentioned, the MX-10 is our foundation and base capability. It's a low-weight day and night imaging system. It takes up roughly 19 kilograms of our payload capacity, so still lots left for other sensors. You can see in the picture here, this is actually a multi-role fit. I'll cover the next sensor in a minute. This is the PT8 Ocean Watch sensor on the nose as well. Really good for UES operations due to its low weight and capability delta. It's ideal for the S100, providing that low-level tactical situational awareness with evidential quality optics. As I mentioned earlier, we can also live feed or export the payload picture into the command centers as well. PicoSAR radar then, providing us with that all-weather capability or times when that cloud base is low. Again, lightweight and compact, very well designed for deployment on a UAV. You can see it on the left-hand side of the aircraft there, circled in green, and some of the resolution from the radar system itself shown below. Optimized for small target detection at sea, and as I said earlier, we use it in a maritime search environment during bad weather and low cloud. Ocean Watch PT8, a wide area optical search system. You can see it fitted to the nose of the aircraft here. What that essentially is a bank of either daytime cameras or nighttime cameras that autonomously search the surface of the water looking for anomalies. Those anomalies are then highlighted to the GCS, to the pilot, on a graphical user interface. He can then slave the MX-10 onto those autonomously found points of interest to interrogate them and identify them. What is also quite useful is it can search by colour spectrum. So, for example, most life jackets are orange or dark red. You can tell the aircraft to look for red or orange things on the surface of the water, and it will ignore everything else. Tali's iMaster, this is a big beastie. You can see this is actually involves a different type of aircraft, longer landing gear. Really challenging for us from an airworthiness standpoint due to its complexity, the power of the sensor emissions from that radar, and its impact to the flight envelope of the aircraft. It took us about 2 months to get this over line with the regulator, working closely with the CEA, Thales, and Schiebels themselves. And we were successful in fielding the radar, however, but due to the aircraft availability and the impact of COVID-19, trials are unfortunately cut a little bit short on that one, which was frustrating for us all, given the amount of work on an airworthiness standpoint to get those approvals.
Cool. So David's talked about just the sensors packs there. We've also got challenges with the airspace, but if I just take a step back, we've kind of alluded to, we've brought this aircraft in. We are an aviation company. We're used to the whole Part 21, the Part 145 air organizations, air training organizations, Part 66 licenses. We decided that we would try and work as closely with the UAS to those regulations as possible. So we have designed the whole system around a Part 145. We haven't got a design office, but we use Schiebel as the design office. We always go back to them for permissions to modify the aircraft. As David said, working with the aircraft to put different radar systems on. So we always have you can always follow the route back to the source, the OEM, of how we've done a modification to our aircraft. And we deal with it as if we have a part camo function. Our relationship with the OEM is through one engineer who deals with reliability data, spares data, all these. So we've built everything around this as if it's a manned aviation aircraft. Our pilots now, going forward, have to have a minimum of a PPL to be chosen to go to Schiebel for the training. That's our minimum standard for them. Our engineers all have to go through the manufacturer's engineering course before they are competent enough to work on the aircraft, and then they go through the same selection and ongoing assessments as our base engineers on the manned aircraft as well. And of course the same assessments for your flight crew as well, David, isn't it? Yeah. So airspace challenges then. We're now getting into the new world for us all. So CAP 722 identifies the airspace segregation requirements for UAS. It's a long time working for us all to get to this point. However, in the absence of some of that, we had to start working with the regulator to get the US specific and what the likelihood of encountering another aircraft was, what the levels of acceptability was. The safety case is now starting to, it was my world, it was great. It's fantastic. The safety case is getting bigger and bigger and bigger to try and prove to the authority and to ourselves that the safety case was fit for purpose and we were fit to fly in different aviation environments, the manned alongside unmanned. And then finally, to get the approval to operate in the airspace and segregated airspace, how did we do it? To TDAs. When we were operating for Carnarvon, we had radar cover. We were quite fortunate there that RAF Valley was prepared to step up and assist us in looking after our airspace and telling us that there's somebody in there, as well as all the conspicuity trials that David's talked about earlier. So we're now progressing into a new era of airspace regulation with the regulator, and we're working with them slowly, slowly, slowly. We're crawling through this airspace change for good reason. We don't want to rush in there. So David, back to you.
Yeah, sure. So just to touch on that and some of the novel work that we did in North Wales to try and provide more porous airspace options for beyond vision line of sight deployment of SAR UAS. A twofold approach, including both detect and avoid evaluation of novel EC equipment and ground-based surveillance technology. So detect trials then, we had the aircraft outfitted with 2 different types of transponder systems. One aircraft was outfitted with Mode S with ADS-B out. Obviously, this is interoperable with TCAS systems that were fitted to our own SAR aircraft. The other aircraft was outfitted with a transponder system from SageTech, also interoperable with TCAS, but this was purely ADS-B in, but also out as well. The UAS was conspicuous on RAF Valley radar, its positional accuracy verified by the SSR radar system. The US was also made conspicuous on third-party radar applications, such as Flight Radar 24, ADS-B Exchange, etc. Key piece as well, the SageTech MXS transponder combined with a software upgrade to the aircraft allowed the pilots inside the GCS to have more situational awareness of other aircraft in the area. So essentially a graphical display inside the GCS that would show those other transponder contacts in the GCS. We also trialled a ground-based ping station solution. This provided a multilateralized airspace picture to air navigation service providers to create a known airspace environment, even at low level, where radar coverage perhaps wouldn't catch specific aircraft operating at low level, such as fast jets out of RAF Valley, etc. Moving on to the more difficult, the avoid. The same MXS transponder from SageTech and the same software upgrade to the aircraft enables a very rudimentary detect and avoid capability. Essentially, this allows the aircraft to detect an aircraft on a convergent path, and it will adjust its speed accordingly to avoid that contact. Unfortunately, progress on that was limited due to the requirement to define and agree success criteria with the regulator on what do you want a UAS to do. Should it be the UAS that's taking avoiding action, or should it do nothing? Should the manned aircraft take avoidance? What type of avoidance should the UAS take? Is speed enough? Does it need to be a heading change? So that work is ongoing, and we're very keen to maintain that with the regulator as we move forward with this. As I mentioned earlier, on the left, that first picture is a screen grab from RAF Valley radar system. The X down at the bottom of the Clyn Peninsula, I hope you can see, is the position of the aircraft. On the right is a screen grab from the ground control station, where we were verifying the positional accuracy of that transponder system. Obviously, when we tell somebody where we are, we want it to be accurate. So that was that verification piece right back at the start of this with RAF Valley. Ping station coverage then. You can see the antennas there. They represent ping station sites up near Anglesey and on the Clyn Peninsula. As I said earlier, they are used to gather transponder data, redistribute that in a multilateralized fashion in a bespoke user interface. So this picture on the right isn't Flight Radar 24, it isn't ADS-B 360. That's the GUI that's inside the RAF Valley Tower, inside Carnarvon ATC, and also inside the GCS, providing that known airspace picture to all air users. So that included FLARM, MODES, ADS-B, and other transponder systems that may not have been caught with Flight Radar 24 or third-party applications. One such third application from a third party was the one you can see on the screen here. Anybody can access this, and we were just comparing the accuracy of those third-party applications against our own technology, really, to see how accurate it was. And you can see the track of the aircraft here.
Okay, thank you. I think, David, you get the number of abbreviations in that last section, if you all kept up with them all. So we're busy working away. We're doing all our stuff as Bristow does. We're looking at this innovation. We're trying to bring it along. We're working with our crews on the SAR base. We're bringing them along on this change journey as well, because they're all scared we're going to replace the whole aircraft with this little UES. And then our MCA colleagues realise, can we have a look? Can we see what you're up to? And we reach this point where they come to us and ask us to do overwatch of the beaches. COVID, the British public have been released. We're all out, having been locked up. We need assets. They need eyes on the various beaches. They would love for us to go down to the south coast, but that's not possible. So we're going to operate in the North Wales regions where we've already got our TDAs. So this is the MCA now starting to integrate that technology into their own control centres. The information, as David said, we don't only feed it back to the ground control station, we can also feed it into their systems via computers, iPads, etc. So they can get live imagery off these aircraft now. And this, for them, is a realization that technology can assist them with the type of rescue they're about to undertake. Do we need to send a Coast Guard rescue team, a mountain rescue team, launch a lifeboat? What do we need to do? The only disadvantage is this aircraft has to be in the area. We can't just launch this and it's going to get there before the manned aircraft. So these aircraft have to be in patrol sectors, going up and down. We can't rely on them launching from the ground and getting to the the target areas before the manned aircraft could because of the speeds, difference in speeds. So David, I'll let you take you through the, well, I'll start it for you. So the MCA now start using the unmanned aircraft. This is their own PR. Does come with sound, but we've turned it off tonight. You can see how they're integrating it into their rescue teams, coordination centers, operation centers.
And you can see right from the start of our trials operations, we're doing things that haven't been done before. We're operating really close to, in really close contact with the S-92 here, speaking on VHF, and it's that man-to-man teaming complex approach that we feel that we can provide as a global aviation service provider, difficult to do.
Okay.
TDAs again, your favourite. So to support those COVID-19 operations and safety overwatch operations in North Wales, we had to again apply for specific segregated airspace to operate the UES to support that urgent operational requirement from the DFT and MCA. This complex supported the deployment of the UES deployed on safety overwatch taskings down the Clyn Peninsula and west coast of Anglesey. Again, live payload feeds from the UES were exported directly, this time into Holyhead Operations Centre, enabling the scene commanders to make real-time decisions based on real-time situational awareness. So what does that look like in real terms? So this is some payload footage from those operations. You can see in the bottom left-hand side, it's maybe a bit blurred, the height the aircraft's operating at. So this is actually at the top of the Menai Straits in North Wales, where we're beginning to conduct these safety overwatch missions. This is the Menai Bridge. As Graham said, people are now back out in small watercraft. The S-92 from Carnarvon has been used extensively for sort of routine operations as opposed to being reserved for its emergency life-saving role. Perfect opportunity to deploy a UAV in that situational awareness role. You can see the fidelity from the camera. This was actually a trials MX-10 as well, so it's actually not as crisp and clear as the ones we operate now. And that's at 1.5 nautical miles range, and the aircraft's around 2,000 feet. Into IR then, you can see this is in black hot, how well those people stand out on the sensor. Again, just to reiterate, the Coast Guard are watching this at the same time as we're viewing it. The light bulb moment. So during one of those safety overwatch patrols, we were deployed to the north of Anglesey on a routine patrol, looking at beaches, people in small watercraft, when we took our first rescue call, for want of a better term, from Holyhead Coastguard, where they had reports of a vessel in distress, which turned out to be a grounded yacht just off the Anglesey coast. We're very close by. The response time was pretty instantaneous. We spun the camera around, and there they were. And we began to move closer to get better imagery of that incident. That, annoyingly, is the leg of the S-100, which passes by on occasion. So you can see here the aircraft is on a feral tilt there, but we've got eyes on now. But we were really quickly able to determine there was no immediate risk to life to the people on board that aircraft. What you'll start to see in the next 30 seconds or so is the general public responding to, I'm guessing, the calls for help from the yacht. So you can see the speedboats coming in, ribs, jet skis, and essentially they self-recover this yacht off the rocks. All the time, we're making sure that situation doesn't degrade. At Holyhead are aware. So the so what of that is, don't have to bother the 92. The RNLI don't need to be deployed. Those assets can be retained because we know what's happening in real time.
So now comes the next stage. We've shown that we can do this. We've proved our ConOps. We've worked with our crews. The MCA can see the utility of this. Now it's time to start putting the money where our mouth is and bring it into our operations. So the Coast Guard asked us to move our trial team down to Lydd Airport and start operating from Lydd in the channel to provide them with situational awareness. And that's where we've been ever since. The program has got bigger and bigger. We've increased the number of aircraft that we have, the unmanned air systems aircraft. We have fixed wing support as well, so it's not just the UAS. And we provide that situational awareness to the MCA Dover Coast Guard in the channel of what's going on in that body of water. There you go, TDA for you.
Didn't have to apply for this one, so this one was already here. So there's less work to do on this one. So this is the area of operations on the south coast, the TDA complex that supports unmanned operations in the channel by ourselves and other entities. It's shared also between manned aircraft as well, so the SAR-H, regional SAR-H from Lydd, other unmanned aircraft, as I said, and other manned fixed-wing assets from our partners and other government departments. Critically, operations have been successful and continue to be safely conducted in that region, with flight being carried out under an agreed all-party deconfliction plan. As Graham mentioned, we redeployed from North Wales under a UAR, and we stood up at Lydd Airport in December 2021, with operations commencing in earnest in March 2022. We arrived with the 2 aircraft, which is one system, and 1 crew, and started best endeavours efforts as soon as we could. In parallel to those initial operations, we began to upscale the capability to meet the HM Coast Guard requirements, growing to 3 crews and 4 aircraft equipped with the additional sensor packages that we trialled in North Wales, so PicoSAR radar, Ocean Watch PT8. They are now in operations in the channel. Our remit then, to provide real-time situational awareness patrols of the channel, providing live, real-time payload feeds directly into HM Coast Guard Dover. The so what of that is a reduction in the pressure on the Lydd SAR crew and other regional SAR crews, releasing them, the 189, to conduct their primary life-saving role. So what does that look like? So routine operations are deployed in a pre-planned fashion and intelligence-based, but we also provide a 30 minutes readiness by day and 45 minutes readiness by night for dynamic taskings as required. Caveat, the airspace has been activated to allow us to fly. We are tasked by the ARCC, just like any other rescue asset. The same phone rings, we speak to the same people, they triage the asset that they want to deploy, whether that be the UAS, the 189, or another aircraft from our partners. And we're the very first UAS asset to be issued with a rescue call sign during operations, designated Rescue 50. The UAS itself is operated, as Graham mentioned, from Lydd Airport, which is an active and relatively busy airport, and it's fully integrated into standard airport operations, just another aircraft operating from the airport. US operations within the air traffic zone are conducted fully under ATC control, so there's no requirement for further airspace segregation. The ATZ is the segregation. Deconfliction within the TDA complex itself, as I mentioned earlier, is procedural and sectorised, with agreed lateral and vertical separation limits between aircraft, be that manned or unmanned. As I also said, that airspace is routinely shared on a daily basis with other manned and unmanned assets. It's as integrated as segregated gets. Lydd ATZ is sanitised for our departure and return to base via agreed approach and departure routes, and then onward transition to and from BV lost flight and entry into the TDA system and complex itself. The US aircrew operate and monitor standard aviation dual VHF radio sets. The only clue we're an unmanned aircraft comes from our initial call sign, that first contact with us. Just another aircraft operating in the sky. As I mentioned earlier, US emits Mode S and ADS-B out and is conspicuous by a designated squawk as required. The US is day and night capable within agreed out-of-hours operating procedures agreed with the airport. So all this sounds great, but what's the actual value? What's the operational effect? To date, we've flown over 800 hours of beyond visual line of sight UAS operations and delivered over 180 rescue taskings. the UES has responded to over 200 incidents, missions that may otherwise have fallen to the LID AW189. We've realised a 66% drop in the deployment of that manned asset from LID for channel search operations, significantly reducing the pressure on the crews and, again, reserving their deployment for their primary life-saving role. So some bonus footage here from our trial operations, not in a maritime environment this time, so this is in Mount Snowdon, where we placed a simulated lost walker in the region and tasked the UES to go and find it. Here you can see some climbers. The fidelity of this will change in a second as the guys hone the IR and calibrate it. So you can see the quality from the IR optics. So you can clearly see two climbers minding their own business, enjoying themselves on the mountain. Realising this is not the people we're looking for, we head off in just a second or two. The heights here are very different. You can see in the bottom left, we're up at 5,000 feet here now to clear that mountainous region, which comes with its own complications, wind currents, etc. So now identifying visually with the EO camera, the daytime camera. As I said, these are not the guys that we're looking for. This is not the lost walker. Here he is, still on the phone to the emergency services as we locate him. The cursor itself is geolocated, so what we can do is we place the cursor on the target. Target's probably the wrong word. Person of interest. And relay those coordinates back to the ARCC, who can deploy either a mountain rescue team, the S-92, or can this person in fact can he self-recover? So again, a change from the maritime operations, but just to show you what we are and can be capable of.
So that's us. We've taken you on the journey.
Excellent, thank you, gents. Questions for Graham and David? If you'd like to approach the mic, it's probably easier if you don't mind. Unless you want to project, you can have a go.
My voice carries enough. How far down the road on using computers and artificial intelligence for processing the imagery live, rather than having people having to watch screens all day?
So the actual payload footage is stored locally as well. I can't go into too much detail on that with what we do after it. But the base capability is that live export. We can do other things with it in a post-process manner. As I mentioned earlier, that footage is evidential quality. The optics are really high grade, and we can do other things with that post-mission.
But we do have AI. We do use it. We're teaching it all the time. We're gathering data, so we're orange and red. We're looking for a person. We're looking for what you're looking for. So we do have hundreds of hours of data now, where we successfully used it to find persons of interest.
Mm-hmm. Persons of interest, not targets.
Tony Osborne with Aviation Week. When you move into the next step, which is presumably SAR-2G, and you want to expand the use of this, how far away are we from having to arrange TDAs, temporary danger areas, and so on, so that you can just send this out there without having to establish all that, and all the paperwork and everything that goes with it?
It's a great place to get to, isn't it? We're probably a way off, aren't we?
There's a lot of work to do with the regulator to realise that still. You can see some of the work and a lot of investment is going in from the company to try and move things forward, provide more options. All we can do is continue to try and push those boundaries with the regulator. We're a global aviation company. We have the SME. We have the evidence base to move that forward, and we hope to be able to realise more dynamic deployment options in the future, because we won't realise the full utility or full potential of these types of systems until that's realised.
Do you have a personal view as to what's holding the regulator back?
That's a good question.
Don't answer that, David. That's a good question. We don't. We're just working with them. We're learning, they're learning at the same time. So don't think they're deliberately holding us back, or we're deliberately holding them back.
I
We're
wouldn't
just working together.
dream of delivery. So I wondered, what is holding them back?
It's just that stepping into the unknown that we've seen the whole way through this process, isn't it?
Yeah.
We sometimes take 2 steps forward and a step back. This just been continuous process that we've gone through with them.
So if I may be allowed to ask a supplementary, which is, when one talks to the regulator, the issue is they don't really, I find, they don't really understand the end game. And you've done very well there and producing a fully operational solution. The problem is the regulator doesn't know what it needs to do to expand that beyond what you're doing. And
Yeah.
I must admit being a little surprised to see how advanced you are, particularly over land.
Mm.
So you mentioned earlier in your talk that you had to provide data. Was it so many flights without an accident? What was the sort of data that was being asked to enable them to say, okay, go ahead?
Cover that if you like.
Yeah.
So the actual trials data itself was part of that airspace change proposal. All the outputs from that trial are available on the CAA website. If you search under Bristow Helicopters, all the outputs from the EC trials, the detect trials, the avoid trials, all that evidence is provided in that report. If you'd like to take a look in there, that should bring you right up to speed of where we are. We invested a lot of money. The EC piece that you look at, we did that, when was that? 2020? So yeah, a while ago now. We were hoping that by now we may have been able to take next steps, but it's trying to define the success criteria with the regulator to certify a system to move forward with. And that's where we are now. We'll continue to work with them to try and achieve that.
The engineering, the Part 145 guys have come along there, they're asking for reliability data, they're asking for camera evidence or equivalence of. So we seem to be getting more and more requests from them for data.
Thank you.
Chris Burley from CFS Aero Products. What level of redundancy and fail-safe do you have in the flight control and comms systems for these aircraft?
Take that. So the primary control link is essentially a large antenna on what looks like a missile launcher. I can assure you it's not. It's redundant. There's the secondary UHF control link as well. There's also another primary link, shorter range. So for example, if the aircraft was to lose link on a large antenna, which it hasn't to date, it will automatically switch to the secondary frequency. We will lose the payload feed, but critically the control can be maintained. If we lose all of it, it's waypoint driven. Each of those individual waypoints has a pre-programmed loss of link protocol. So for example, it can move to another area till it regains control. It can come back to base, land and shut down autonomously. There are lots of different pieces and mitigations in place that are redundant parts of that system. The aircraft itself, several parts are redundant. The ECU, the fuel pumps, the servo actuators, and critical flight controls are redundant on it as well. If that answers your question.
Oh, right at the back.
Obviously, Bristow is historically a very rotary wing focused organisation, and you've chosen the rotary wing platform. Its both speed and endurance tend to be more the preserve of fixed wing. I wondered whether your background in rotary in any way influenced your choice of platform, and whether you would in the future look perhaps towards more of a fixed wing approach with maybe the VTOL option.
As a rotary firm, yes, we're much more comfortable in the rotary environment, so you're right there. For us, the future, we're looking at fixed wing. We're looking at all these options for the different things we want. We're not fixated on the S100. That gave us the ability to do all these trials, especially the sensor packs, understand the chronauts that would require for search and rescue. Where we go next into SAR2G and what's the future, it's open. We wouldn't dismiss fixed wing because we see the utility in that faster speed, the endurance of the aircraft, the loiters, all these things, which the fixed wing will bring us, but the rotary wing doesn't.
Thank you.
It's quite good, this, putting the bike right at the front.
Sean MacDonald, RAF Air Cadets. Just wondering what kind of things you've got potentially in the pipeline for transmitting the data from the UAS to perhaps the rescue helicopter or lifeboats, etc., so they have the benefit of that enhanced data.
So we have, as part of the SAR second generation contract, we have that very system which we're working with the various design offices now to bring all that information to all those, whether it be a mountain rescue team, a lifeboat, or other aircraft. So aircraft will transmit data to each other. That's part of SAR 2G. You'll hear us call it the OneLink system. OneLink brings together our ISR, our C4, our video imagery, and puts it into our mission systems, our mission stations on the aircraft, the mission systems in the command centres, and then down to iPads, if required, on the various assets. Brings a long screwdriver with it, so we have to be careful of that.
Time for a couple more, I think, if anybody's got the one. So with an eye on the future then, chaps, so air-launched effects are a hot topic in the military domain. Do you see potentially complementary to this, there being operational utility for search and rescue to have kind of an organic launch capability such as that?
We haven't taken anything off the table for the future, that's for sure. We're trying to understand, develop. We've not stood still with the UAS program, but we have paused with COVID and then bring it into operations earlier than we thought. And now we're starting to gain speed again to look at what the future is. And those working with the military, understanding their needs, is one of the many avenues that we have to explore as well.
I may ask this earlier, but in terms of getting some kind of first aid via the UAV or perhaps some kind of life raft, is that also part of SAR2G at all? Or?
It's not part of the SAR2G proposal, but the proposal allows us to expand anyway. So the bid, but as you were talking to David earlier, we have trial dropping objects from the aircraft. You can't exactly carry a full airborne life raft on this. It wouldn't get off the ground. But you have deployed life jackets.
Yeah, self-inflating life jackets in North Wales from a drop box that fits to the left-hand side of the aircraft. As we mentioned earlier, you either get one life jacket or 50. It's not compartmentalised yet. It's a work in progress with the operator, but we did trial that, yeah. It is possible.
But again, you'd probably send a manned asset. You could pretend this got there. It'd be very different. Yeah. So. Yeah.
How many S100s do you have? Are you interested in multi-agent autonomy? What are some of the most common search algorithms you use?
Wow, search
algorithms.
Bring in the geeks, come on.
So it's,
so there's 4 S100s, so 2 systems that we have currently that we operate. The search algorithms.
I can cover that.
Yeah.
So the aircraft itself has some inbuilt capabilities, so you can literally select a box. So you get a track line search, a radius search, but most of the time we're flying it in a, for want of a better term, a manual method, in a pre-programmed or a pre-authorized area. That's how we conduct ops. But for example, if we're tasked to do an autonomous search, we can select an algorithm within the system and it will carry out that autonomously for us. Not sure if that answers your question, but
Probably what's the actual numbers.
When you've obviously got two types of sensors, what defines how you use the one with the LiDAR and the one with the radar?
Yeah, cool.
environmental conditions normally. As we mentioned, the MX-10 is always fitted. That's our base capability. The bit that gets in the way normally is the good old British weather. Our operating height, sometimes the clouds below us. And that's when we'll deploy the radar system. So we still have that detect function. We may lose the identify function. If it's patchy cloud, for example, we may take an opportunity to slew the MX-10 on to a target that to a point of interest we've identified with the radar system. That really drives that.
But the aircraft itself is capable. We did a trial with the MC last week, maybe the week before, where it was there was no visual, and the aircraft took off automatically, headed off to its target area, and came back without any issues.
And we just pass on those radar contacts to aircraft that are either lower or able to get closer to that contact.
In fact, we were still seeing targets with the radar, weren't we? So.
Mhm.
Excellent. Go on then. Yeah, quick one.
Just curious, is the S100 all weather capable, for example, can it fly in icing conditions?
No,
It's,
it has limitations. It's pretty good in the rain. We have wind limitations just like any other aircraft. But icing conditions and thunderstorms, no.
Excellent. Thank you, gents. That was a really enlightening brief and yeah, very impressive capability that you've established during challenging times with COVID and also a challenging regulatory environment as well. If everyone would like to join me again in thanking the
You're welcome.
Thank you all again for attending the lecture. We've just got a small token of gratitude from the society. Just take some
thank you very
wrapping, but thank you very much.
This is it. This is what you wanted.
It's, should survive the trip back to Aberdeen.
David, you're in charge.
Shotgun, not keeping that
If
safe.
this breaks, it's down to you.
How's the handling?
There we go. Thank you very much.
Fantastic.
Thank you.
Thank you, gents.
You're very welcome. Thank you.
Thank you.
Thank you. Cheers.
Excellent. Thank you, everyone.